Okay, brother. So let's do a summary for the whole question, and then after which we will do the so-called the non-homogeneous equation. Okay, which is what we call the Coulomb friction. Okay, the Coulomb friction, where we are dealing with the 4F over K difference between amplitudes, measures amplitude difference between two cycles. Apparently this will be like 2 days later or 3 days later that I will do. So yeah, because I already spent about, now it's 8:31. I started off about 5 o'clock. I already do for 3 hours already. Okay. So anyway, so yeah, uh, yeah. So the first step, as clearly defined in my notes, okay, is that you have to first understand the movement. Okay. So we already define by also understanding the free body diagram. Okay, so we define our sign convention plus and minus because we are dealing with the torque, and then we decide our pivot, whether is it the center of mass. If the mass is over here, then it's different case. If the mass is over here, then we have to bring this all over here. Okay, this is one key thing I need to know. It's pretty nice. At least I found out the truth of this, which is, yeah. Anyway, so and then what do we have? And then define the mg, and then 4 3 0. Okay, then we define the length, we define whatever thing that we need over here. So eventually we solve for the we need the equation for torque equals to F for times d, and then we have the torque is equals to moment of inertia times the angle per second. I mean acceleration per second of the angle itself. It's just the movement of the vibration of the rod itself lah. So if you are dealing with angles, okay, you are dealing with angles, you are dealing with this. Okay. If you are dealing with distance, then you are dealing with this. It's just one D that's doing this. If you are doing with in terms of a little 2D, I think so. So you're dealing with angles, I think, yeah. And then after which once we set up the equation already, so we draw a free body diagram, very important, and we state all necessary parameters, and then we do a summation of moment, and then we set up the equation, and then we have to find ways to simplify the equation, which is the very very tedious part. As you can see, the whole chunk is just to simplify the equation. So we need to first, if the center of mass is not in the correct place, you use parallel axis theorem, and then you have to assume certain assumptions. You have to assume the rod and the mass. You have to make sure the equation is as simple as possible. So you have to make sure a lot of things equals to 0, which is, yeah, seriously, that's a little tough part over here. And then simplify, assume the length of the rod much greater than the length of the point load. Yeah, so as you can see, we assume that the mass is, as I say, it's much smaller than the length of the whole rod. So this is why we assume it's 0. Then we further simplify, and then we got here. Yeah, just one equation. Damn. Okay, so this is a pretty, yeah. If he didn't teach us, then this is it, lah. Yeah, and then you further simplify, you just sub it in, because now we are actually finding this portion only. Eventually we have to solve for this equation, but we have to simplify this equation such that this equation can be much easier to solve. So therefore we sub in the the moment of inertia into here, then we just do a little magic here and there, subbing in and making some assumption and things like that. Yeah, especially this why we emoji. This is the part I little, yeah. And then we just do all the stuff like that, and then we rearrange, but then we have to compare. Okay, so comparing is one key thing. K over, it's like a B over A type of thing. I mean C over A or whatever. K over M lah. Okay, so wherever coefficient in front of M, you just bring it down there, so 9m over k over 9m square root. So this is the one of the key things I need you to know. And then the assumptions, because you cannot eventually make it to 0. If it's 0, then a lot of things becomes, because let's say if you put sine 0, then everything will become 0, which is totally makes no sense, because we will assume that because the thing will vibrate definitely, you will not vibrate, you will continue to vibrate, so therefore we will assume very small vibration, small oscillation, so therefore we can still let the equation to run. Yeah, so these are the few assumptions, I mean a lot of assumptions, so hopefully I make this whole thing clear, and then the next video I'll start off with the the column friction, which is another huge stuff. So yeah, see you soon, bye bye.